We are going to find a volume using polar coordinates. It is the volume of the solid that lies below the cone z equals the square root of x squared plus y squared, and above the ring x squared plus y squared is between 1 and 4. Let's see if we can get a sense of what this looks like. Here we have the disk or the ring in the xy plane. It's between circles of radius 1 and 2. And then we're bounded above by the cone here, and so it's kind of like a shot glass. Now for our region D, we've got that R is going from 1 to 2, the radii of the edges of the ring, and theta is going from 0 to pi to 2 pi, Now what's left is to convert the equation of the cone. Since z equals the square root of x squared plus y squared, z must equal the square root of r squared, which means that z must equal to r. And we don't need absolute values because r is positive in our picture. The volume is then given by the integral from 0 to 2 pi of the integral from 1 to 2 of r is the integrand times r dr d theta for dA. This time we can split this up into the integral from 0 to 2 pi d theta times the integral from 1 to 2 of r squared dr. This is going to be fairly straightforward here. We end up with 2 pi times 1/3 r cubed evaluated from 1 to 2. That's going to give us 14 pi over 3. Our next example also involves a conversion. We're to evaluate an iterated integral by converting to polar coordinates. Our integral is from 0 to a of the integral from negative square root of a squared minus y squared to square root of a squared minus y squared. The integrand is 2x plus y, and we are given dx dy was the original order of integration. For our region D here, we have that x is between the negative square root of a squared minus y squared and the positive square root of a squared minus y squared. Also, we have that y is between 0 and a. Taking just one part of the inequality involving x, we can turn the boundary into an equation. X is equal to the square root of a squared minus y squared, which means that x squared is equal to a squared minus y squared, which means that x squared plus y squared is equal to a squared. Folks, when you get used to this, you're going to recognize these kinds of limits with the negative square root of a squared minus y squared and positive square root of a squared minus y squared. You're going to recognize that as part of a circle. In this case, our circle is of radius a, but we only have the top half of the circle because y only goes from 0 to a. In other words, y doesn't go negative, so we have the semicircle that lies above the x-axis. With that in mind, I'd like you to see if you can complete this exercise. Go ahead, pause the video, come back when you're done. Based on our diagram, we can see that theta is going to go from 0 to pi, and r is going to go from 0 to a. Our integrand was 2x plus y, so we have that, now I've labeled it I for the integral. I is equal to the integral from 0 to pi of the integral from 0 to a of the quantity of 2r cosine theta plus r sine theta times r dr d theta. I was able to factor out an r, and since we have constant limits of integration, we can go ahead and write this as a product of two integrals. One of them is from 0 to pi of 2 times the cosine of theta plus the sine of theta, all that d theta, times the integral from 0 to a of r squared dr. That will integrate to 2 times the sine of theta minus the cosine of theta evaluated from 0 to pi, and then for r squared we have 1/3 r cubed evaluated from 0 to a. Since the sine of pi is 0 and the sine of 0 is 0, we're done with the sine function. And the cosine of pi is -1, but that's preceded by a minus sign. The cosine of 0 is 1. Substituting a in place of r for 1/3 r cubed ultimately finally will give us 2 times a cubed over 3. Why I circled that in pink, I do not know, but there we are.